All right. Well, good morning, good afternoon, everyone, and welcome to today's Exploring by the Seat of Your Pants event. My name is Joe Grabowski, and I'll be your host for today. We are quickly moving through October. October is always a really busy month for us here at Exploring by the Seat of Your Pants. It is our space exploration month, so we're talking to astronauts and scientists and engineers from the Canadian Space Agency, NASA, JPL, and other cool organizations, learning about what it takes to leave our planet, to explore outside of our solar system with robotics and things like that. We also have our Wild Hope events coming up towards the end of the month, where we're learning about really cool conservation stories from different filmmakers, biologists, and researchers around the world. And then we're also doing a little bit of events for Science Literacy Week. So it's a series showcasing the amazing scientists in our federal government. And we just so happen to have one of them hanging around backstage with us right now. We have Chris Derksen with us. He is a research scientist with the Climate Research Division of Environment and Climate Change Canada. So his research activities focus on using satellite data and climate models to understand how climate change is impacting the Arctic. So the best part of his job is when he gets out into the field for some field research. He's participated in more than 25 snow and sea ice measurement campaigns across our Canadian Arctic, which is pretty cool. So I'm going to reach backstage. We'll see if we can find Chris there. There he is. Hey, Chris, how you doing?
Doing very well, Joe. Nice to see you again. Thanks for having me on.
Yeah, of course. Always great to steal a little bit of your time. Great with it being Canadian or Science Literacy Week here in Canada. And yeah, I mean, you split your time between the office, the desk, and out in the field. But I think like most researchers we talk to, they treasure and look forward to their time out in the field.
That's absolutely right. We always have a saying in my research team that a bad day in the field is better than a good day in the office. And I think that that definitely is something I subscribe to. It's the best part of my job.
Excellent. We've got classrooms joining us from different parts of Canada. A lot of them are joining via the YouTube live stream. So a shout out to them. Don't be shy to use the chat sidebar and send in some questions. I see we have EF5A backstage. Give me a big wave, EF5A, if you can hear me okay. Excellent. Good. Okay, Chris. Well, I'm going to let you take over for a little bit. Then we'll get into some Q&A action.
Sounds good. I'll share my screen, see if I can do this right, and get my slideshow in the full screen mode. And I think I need to swap my view, and then I need to get rid of this guy. And there we go. That should be good. Is that good, Joe?
You got it. We're ready.
All right. Okay. Well, thanks for joining today, everybody. I'm going to present a little bit about my experiences working across the Arctic, measuring snow, measuring sea ice, measuring ice sheets. And then at the end, I won't talk for too long. I'll try and show you lots of interesting photos. And then at the end, if you have questions or things you'd like to ask or share, I would love to hear from you. So just a little bit about myself first. So I work with a research team at Environment and Climate Change Canada. So we're a government department here in Canada. And what our team does is we use satellite data. So instruments that are orbiting our planet on satellite, they make measurements of our Earth's surface using all different types of instruments. And we use those measurements to understand how climate change, warming temperatures that we're seeing across our planet, how that impacts the Arctic, specifically snow and ice. And for me, as you know, Joe already mentioned, my favorite part of the job is getting out into the field. And we have to go into the field because We really need to trust the data from satellite. We need to trust this remote sensing perspective that we get on our planet. But we have to make measurements in certain places at certain times to make sure we're validating or understanding and using the satellite data properly. So I started doing this quite a while ago, and the favorite part of my job is when we get out in the field to make measurements to support our interpretation of the satellite data. So this photo is me up near a place called Eureka in the Canadian High Arctic. It's an island called Ellesmere Island, and you get really big chunks of ice that break off the Greenland ice sheet and other ice caps in the Arctic and float down and get frozen into the sea ice around Eureka. So this is a picture of me with some of my colleagues one year, and we were working out of Eureka. I thought I'd show a couple older photos of myself too. I've always been fascinated by snow and ice. So when I was a little kid, I liked reading about Arctic explorers, Antarctic explorers, and I love to build snow forts and play in the snow. I'm not sure what I was trying to build here, and I'm sure I got some help maybe from my dad. But this is some kind of janky looking snow fort that I once built when I was, I don't know, around 5 or 6 years old. When I got a little bit older, my first trip to the Arctic was in 1994, so that feels like a long time ago now. I had a little less gray hair in these photos, but these are just a few random selections of my first trip to the Arctic when I spent almost 3 months living in that orange tent that you see on this slide here with a couple of other colleagues. We were making measurements. We had instruments. We flew on this red balloon that you see in the bottom right-hand photo. So my first trip to the Arctic was a long time ago, and I've been very lucky to go back many times since then. My own personal research, my own expertise over the years, I've studied and developed a lot of research on snow. So, snow is one of my favorite materials that we have on the Earth's surface, and it's really, really important to us for many different reasons. So, the first thing is that snow is water. So when snow melts in the spring, it provides fresh water to us. And in Canada, a lot of the fresh water that we use for cooking, we use for drinking, we use for doing our laundry, all of that fresh water. A lot of it comes from snow that melts in the spring or glaciers that melt in the mountains during the summer. So we really benefit a lot from what snow brings to us when it melts. As you know, when you go outside in the winter, snow is also really bright. On a sunny day, you have to wear sunglasses when you're out in a snow covered area. So, what that means is that energy from the sunlight bounces off of snow covered areas, and gets sent back into space. So, what we really think about is that snow will help keep our planet cool. So, if it wasn't for snow, our planet would be much warmer than we have right now. Snow also is a good insulator. That's why if you make an igloo or you make a snow fort, it actually gets quite toasty warm inside because snow is really good at trapping heat. So what that means is ground that's covered in snow is a lot warmer than that ground would be if there was no snow on it during the winter. So lots of animals, of course, live in the snow and on the snow and move through the snow. So there's a real like terrestrial ecosystem component to snow cover as well. That's why it's super important. And we also know that snow responds very directly to climate change. If it's not very complicated to think about, if you warm temperatures, if things go above zero, the snow melts. So if we shift springtime a little bit earlier, we melt the snow a little bit earlier. If we temperatures cool down a little more slowly in the fall, in the autumn, then we get snowfall occurring later in the fall. So we're seeing a lot of changes to snow across Canada because of climate change. Some things to think about, like the things I think about when we're trying to measure snow, is like when you're walking in the snow, is snow the same depth everywhere? Is it like a uniform blanket? And the answer is no, it's really not. It moves a lot. Wind will move snow around. So we think, what makes snow move? Well, wind makes snow move. And if you look at this picture I took many years ago in the Arctic, in just one small area, there's bare ground. All the snow's been blown off the area that looks brown in this photograph. But if you move just a little bit further away in the photo, you see this massive snowdrift in the background. So here the snow is maybe 5 or 10 meters deep. So in one very localized area, you get a lot of bare ground and you get very deep snow. So that makes snow really tricky to measure. We can't just go to one spot and measure it in that one spot. We have to think about how it varies across the landscape and think about what that means. So the other thing that's really cool about snow, maybe my favorite part about snow, is that when you dig in the snow, when you look at the snow crystals, the individual snow grains or the individual snowflakes, are they all the same shape? And I think we all know, or we heard many stories that no two snowflakes are alike. That's true, but there's also many different types of snow that we see in the snowpack during the winter. And that's because when snow sits on the ground, it doesn't just stay as it was when it fell. It changes, it evolves during the winter season. That's because it gets warmer, it gets colder, more new snow falls on top of it and compresses it down. So we get lots of changes in the vertical properties of the snowpack. And it's those changes in the vertical properties that are really important for how well the snow insulates the ground, what the density of the snow is, how much water is stored in solid form by that snowpack. So lots really happens within the snowpack that's super interesting. And I really like to show these photos. These are photos that were taken through a microscope. I did not take these. These are photos that I found from some other scientists. But what you see here is different ages of snow during the winter season. So when snow falls, it looks a lot like these snowflakes in the top left of this slide. So these are those kind of classic snowflakes that have the six arms, sort of what we expect to see when we would envision snow falling. But once that snow falls, it doesn't take very long before these snowflakes start to decompose. And that's because maybe the wind blows them around, so they bounce off other snowflakes, or it gets a little bit warmer and then colder and then warmer and colder, so they maybe melt a little bit. So you see that these nice, pretty pristine snowflakes we see here, they start to evolve, they break apart, they erode down into these like fragmented pieces. Then from there, as they get a little bit older, maybe a month goes by, they start to take this kind of rounded shape where all the fine structure of the snowflake, the arms, all the delicate designs of the snowflake, they're all gone now. They've been broken apart, they've been worn down, they've melted down, and you get these more rounded forms that you see in the bottom right of the slide. And then finally, if snow sits on the landscape for many, many months, it starts to look like these snowflakes or snow crystals on the left. They take on the shape of a cup or a big flat surface. And these are pretty large grains. And I'll show you some photos of these that I've taken in the field a little bit later. But these can be the size of my thumbnail. So it's really cool because a snowflake that starts the winter looking like this in the top left, after many, many months, it looks like these kind of forms. It's a bit hard to tell in two dimensions in this photo, but they take on the forms that you see here, changing completely their size, changing completely their shape, and they start to look like that. So snow is really a dynamic material. It changes a lot throughout the winter season. So why do we use satellite data to monitor snow in Canada? Well, Canada is a really big country. I think we all know that, and it has many different land cover types. So some of Canada is forested, some of Canada is open prairies, some of our country has tall mountains, and in each of these areas, the snow has different characteristics. It's deeper, it's shallower, it's more dense, it's less dense. It interacts with the vegetation, or in the case of the Arctic, there's no vegetation at all, so it evolves differently. So to understand how snow is changing across a country as big as Canada, we need to use satellites. This is a composite of satellite images here that show just for one date what the snow cover looks like in the winter. And so it's kind of cool that we can see patterns like this from space. And in this image, even in the top right corner, you can maybe see the bottom tip of Greenland that's showing up in this image here. So kind of a cool satellite image. This is what the Arctic looks like in the summer if you take satellite data and look down on the North Pole. So like think about the North Pole as being in the center of this image here. Um, and what you can see for two different summers is what the Arctic sea ice looks like during the sort of July, August period. We took a lot of different images and averaged them together to make what you're seeing here. This was 2005, quite a few years ago, and this was 2007. And you can see each summer, the pattern of sea ice that survives the melt season in the summer takes a slightly different shape. And you can see in the Canadian Arctic here, in 2005, there was a lot of ice in the waterways between the islands, the channels between the islands. But in 2007, most of that ice was gone. It melted that summer. So that really gives you a sense of how important satellite data is to help us understand how things are changing over large areas. I'm going to try and get this animation going. This is going to move really fast, but this is satellite data showing Greenland here on the right, the white blob on the right, that's part of Greenland. This is Ellesmere Island on the left. And you can see, maybe you can see the sea ice here kind of shifting around. This is data captured every day for over a few months period. And you can see, maybe we'll focus on this area. Hopefully you can see maybe I'll try to put my laser pointer on. Here we go. You can see this area here where ice is breaking off here and flushing down through Nares Strait. This is called Nares Strait. You can see the ice moving through here. So we would have no way of understanding and mapping ice motion, no way of predicting where there could be icebergs that are unsafe for ships. We really wouldn't be able to understand how sea ice changes and what's going on unless we had satellite data. Let me just move. I think I'll skip that slide. So I thought what I would do now is just move you through a number of different photos that show you the types of work that we do, the types of measurements we make when we're in the field. So this is a photo of me from a few years ago holding this, what looks like a ski pole. And this was an ingenious device that one of my colleagues who lives in Alaska, he invented this. And it really made our lives easier because when we were measuring how deep the snow is, we used to have to stick a ruler in the snow and then look down and then take out a notepad and write down the number and then move ahead and do it again. It was very tedious and repetitive. And then afterwards, we had to type in all the data. It was not a really fun part of the job. But this device measures the snow depth automatically. It has a little basket on that pole. The basket sits on top of the snow. When you jam the pole in, you press a button and it measures the snow depth. And there's a global positioning system, a GPS attached to it. So it tells us where we made the measurement and how deep the snow was. So we can bang out thousands of measurements a day with this instrument. It's really made our lives easier. When we're working in the Arctic, a really fun part is we have to get out on the land, away from communities, away from where people live, get out into kind of the wilderness, into open areas and make measurements. And sometimes we go to where there's field camps and sometimes we bring the camp with us. And on the photo that I'm showing here from this trip, we had everything with us on our sleds that we're towing behind our snowmobiles. We would go out, and in this case, we spent many weeks camping in the winter on the land. And then during the day, we would make measurements and then we would come back to our camp and spend time there in the evenings. This is some measurements of ice thickness, and this gives you an idea of how thick the ice can be in the Arctic. So this is kind of a before and after photo. This is one of my colleagues standing on a snowmobile. This is how long the auger probe needs to be, the flights on the auger, to drill through the ice. It's more than 2 meters. And so he has to stand on the snowmobile to get it started. Once we just start to punch through into the water beneath the ice, you can see how much of that auger is now buried into the ice. So it's almost 2 meters. And if you're a little bit cold when you're working in the field, being the person who drills this auger through the ice, that's a great way. That's a great way to get warm. It's a lot of work. All right. Sometimes we stare intently at the snow. This is me looking through a field microscope to look at the specific shape and size of the snow grains. And this is one of those cup-shaped forms that I talked about earlier. This is a photo I just snapped with I think with the camera on my phone one year and just showing you how large this is. So this grid behind it is 2 millimeters. So this is about 8 millimeters by 8 millimeters. So yeah, about as big as one of my fingernails. One really big snow grain that we found at the bottom of the snowpack. Sometimes we put instruments on airplanes and we can then control, where we make the measurement. So this was a photo we took one year. We were camping in this tent and we had a plane fly by. In this case, it was coming into land. It has skis on. And we worked closely with the pilots to make some pretty cool measurements that year. Sometimes we work in areas where there's stations set up that make measurements continuously. This is a station in the Canadian Arctic that measures temperature, precipitation, solar radiation, all the things we need to know about the environment, wind speed, wind direction. And this runs all the time, and we can use the measurements from stations like this to understand what's happening on the landscape. I thought I'd show you a little bit about how we live in the Arctic. We sometimes fly into camps by plane and live in tents like this. Sometimes we get to live out in smaller tents like I'm showing in this photo here. And this was a really cool photo because you can see a bit of northern lights up in the top left and you can see that's the moon here with a planet. I think it was Venus or Mars is that bright spot beneath it. So you really get to see some cool things in the night sky. I always like to include this photo because it just shows how cramped our tents can be. So that's me lying on a cot here. You can just see the head of one of my colleagues sneaking into the photo over here, and a third person sleeps alongside here. So we're in very close quarters. So we always say you better be good friends with the people you're working with in the field, because you're going to spend very close, you're going to be in a very close space with them. And if you look up here, we have socks and gloves and boot liners, lots of things drying because things kind of get wet during the day. So it's not the freshest scent sometimes in this tent either. So you have to be very cozy with your colleagues. I've recently had the good fortune to do some measurements in Greenland. So we measured snow on the ice sheet, snow on the Greenland ice sheet. Greenland is a pretty cool place. It has some really big mountains. We were there in June this past year, so the snow is starting to melt along the coast, but lots of snow still in the interior of the ice sheet. Just a couple of photos to give you a sense of what the coast of Greenland looks like. Pretty cool place. And this was one of the coolest places I've ever been. This was in the center of near the center of the Greenland ice sheet. You can see this big black dome here and lots of tents set up around it. This is where there were people working for almost 5 years to drill a hole from the top of the Greenland ice sheet all the way to the bottom, which is about 2 kilometers, just over 2 kilometers thick of ice. So a lot of ice. It took them a long time to pull a core, a 2 kilometer long ice core out from from this site. So we were able to visit there and make some measurements as well. So pretty cool spot. And this is just showing you the hole. So this tube, you can walk in these tunnels underneath the snow. And then they had just finished drilling when we got there. So this tube here, this green tube that you can see going down, this gap in the ice, this goes 2 kilometers down from where they started to drill here down to the bottom of the ice sheet. And I asked one of the scientists, what did you find when you got to the bottom of all the ice? Because I thought maybe there's something pretty cool down there. And his answer was a little bit of water and a little bit of mud. So I thought that was a pretty underwhelming answer. You drill all that way, and that's what you find. Not too exciting, but still cool. So we get to fly around the Greenland ice sheet. We service weather stations like this, and we make measurements of the snowpack. It's just like we do in the Canadian Arctic, but doing it in a different place. And again, Greenland is just a really cool place. Lots of glaciers. Some glaciers look really smooth, like this one on the left. And then some glaciers that move really quickly, they fracture, and you get these really cool patterns like you see here, where the ice is kind of breaking up as it moves from the top of the Greenland ice sheet down towards the coast. So the last thing I wanted to do is just show you a bunch of photos of the interesting things we see. So the animals and other sorts of interesting things we come across when we're working in the Arctic. So this is a photo of birds that are quite common in the Canadian Arctic. They travel around in a flock, in a big group. They're called ptarmigan, and they're quite well camouflaged because they're white and they stand on snow, but they're not quite as well camouflaged as they think they are because they have a black beak and a black eye. You can see them, but their main defense mechanism is to just stand very still. And sometimes I feel like they forget that they can fly. You can walk right up to a ptarmigan. They're not easily startled. They're kind of a funny bird. And this is the tracks that they leave in the snow. So it's always easy to spot when you've come across where some ptarmigan have been, because there's lots of them in a group and they leave these really cool footprints in the snow. This is a really interesting story that I want to just tell about how these footprints were made in the snow. So you can see these round footprints that kind of dot their way across this bare ice. What happened here, I think, was that quite a big, heavy creature like a polar bear walked across this area when there was snow completely covering it, soft snow, fresh snow. And the weight of the bear made these compressed, footprints. Then it must have gotten windy and all the fluffy light snow blew away, but the snow that had been compressed by the polar bear stayed in place. So what you're left with is this track that shows where the animal walked across the snow, like a reverse footprint. Really kind of cool. We see a lot of Arctic hare. So this is a bunny that we saw, also quite well camouflaged. You can see the white coat there. And this is the bunny, same bunny being chased by a Arctic gyrfalcon. So it's a bird that hunts prey. And we were fascinated by this back and forth. This bird chased this bunny for a long time, about 45 minutes. And I was happy for the bunny because it never got caught. It managed to evade this bird the whole time. But you can see it was a pretty harrowing moment, I think, for the bunny. We see a lot of caribou. So these are animals that travel in quite large herds across the tundra. And they're really cool to see large groups of caribou moving across the land. I think this is my favorite animal that we see in the Arctic. This is a muskox. We took this photo close to Eureka, where I showed you one of the first photos in my presentation. Muskox are really cool because their defense mechanism is to stand in a circle. So they put their head facing out and their butts facing in. And if they have young with them, they put their babies or their young in the center of the circle. So they create this sort of defensive ring around their young. And we keep a safe distance away. We don't want to bother the muskox. But because they stand very still and they stay in this circle, you can get really cool photographs of them. So this was taken quite a distance away, but with a pretty good zoom lens, and we got this really cool shot of the muskox one year. Sometimes we see random things that we don't really understand. I once dug a snow pit in the middle of the Canadian Arctic and a spider popped out of the snow. I've never seen a spider in the snow before. I have never seen one since. It was really bizarre. This is some polar bear poop that we came across one time, just sitting on the snow. That's my glove there. So pretty good sized deposit from the polar bear. And these tracks were kind of walking away from it. So we came across a place, obviously, where the bear did his business. We see a lot of northern lights. So these are really cool patterns that we see in the sky. This is a photo from from northern Quebec. The province of Quebec has a really cool Arctic portion of the province in the north, and they get some really cool Arctic northern lights. This one always kind of reminds me of of a donut or some kind of swirly shape. And this photo is cool. We were doing some field work in northern Quebec, and some of the Inuit elders who lived in the community close to where we were working, they decided they want to come out. They wanted to come and stay with us. So we stayed in our tents, and they came and built an igloo beside us, and they would fish during the day while we were measuring snow, and then we would come back and have dinner and hang out with them in the evening. So I think their igloo was a lot more comfortable and cozy looking than our tents were. But this photo was cool because you can see the lights on inside the igloo and some northern lights above it. And this is called a sundog. If you can see in this photo, this is my colleague is standing in the middle, blocking out the real sun with his head. So the sun is in the middle of the photo. And then on the left and the right, you can see these little rainbows and additional, looks like we have three suns, right? One sun, two suns, and another one on the left with that rainbow pattern. And sundogs occur, you really only see them in the Arctic. I haven't seen them anywhere else. When the atmosphere is really cold and there's little ice crystals in these clouds that you're seeing on the horizon here, it can reflect the sun because of the angle of the sun and create this sundog effect. So really super kind of cool patterns that we see in the sky. So I hope that gives you a bit of a flavor of the kind of work that we do, making measurements of snow and ice across the Arctic. And we do this because we want to be able to understand the satellite data that we use to monitor and to map our planet. And so if you're thinking about things you might want to do in the future, things you might want to study, remote sensing, use of satellite data, it's super fascinating. I've been doing this for a long time. I think it's a really great field. If you're interested in the science part, you can use the measurements the way I do to study different things, the oceans, forests, snow, ice, whatever you think about. But even within the field, you can do, if you're interested in the satellite technology themselves, you can become an engineer. You can design and build satellites. We have to launch them into space. We have to think about how satellites orbit. What orbit do we want them in around our planet? What are we going to do with the data once we have the measurements? So, really fascinating field that maybe some of you will also find interesting when you get older. And then I'm going to put this slide in. This is maybe more for the teachers than for the students, but I just wanted to, because I work for Environment Canada, a lot of the work, well, Environment and Climate Change Canada, that's the proper name of my department. We do a lot of work to understand how warming temperatures across the world impact our lives in Canada. And one of the interesting things is, we've definitely seen warming across the planet over the past 150 years, but especially over the past 50 years. But we really don't know what the future will look like for Canada. We use very complex climate models that simulate what future temperatures will look like. And it really depends on how the international community comes together to think about our emissions of greenhouse gases. And in the future, Canada could look something like we see on the left map here, where temperatures are a further 1 or 2 degrees warmer than we're seeing now. But there's also a scenario in which, by the end of the century, which is really only like 50 years from now, 60 years from now, Canada could be 5 or 7 degrees warmer than it is now. So that's a big difference. So we really want to think a little bit about understanding how our climate system is changing and what that means for us, and how, as Canadians, we're going to have to adapt to climate change as our country becomes warmer. So I hope this gives you a little bit of a sense of the work that I do and why I like my job so much, and why I always am engaged by my work. And I love coming to things like this and talking to students about the work I do. And I'm happy to stop talking now and listen to you and answer some of your questions. So I'm going to take a drink of water and then I will be ready to go. And I think I see a few questions in the chat already.
All right,
Thank you very much
perfect.
for listening.
Well, thanks, Chris. Thanks for a great presentation and taking us out into the Arctic to see some of the cool work you do, but then to see some of the work that, maybe you do from the desk as well, looking at those satellite images and figuring out what it all means, and then getting out there on the ground to kind of truth some of that as well to make sure those things kind of match up. Before we get into some Q&A action, we are going to play a little Kahoot together with the classroom. So while you're presenting, I pulled together a few multiple choice, a few true and false questions. I'm going to share that screen right now. If any classrooms want to join us today, you can do so by going to kahoot.it, and then the PIN number for today is 5273066. You can join from your seat. Maybe you have Chromebooks or tablets. Great. Otherwise, this should be at the front of your room right now, so you can just play along with your teacher and shout out your answers to him or her. If you're joining from home, you can even scan the QR code and it will bring you right in to play along. While we wait to see if we have a couple groups come and join us directly, Chris, you did notice a few questions in the chat, so let's tackle a couple of those before we play Kahoot. So we saw evidence of polar bears, but we didn't see any. So do you see them? Are you lucky enough to get to see them themselves?
I think I have seen polar bears a couple of times, 2 or 3 times. So we did some work in a place. The community is named Churchill. It's in Manitoba, northern Manitoba. It's right on the coast of Hudson Bay, and they get a lot of bears in that area. So we were pretty sure we'd see some that year. We did see one that was kind of curious, but it was at a safe distance. That's the thing with polar bears. They are really cool. So I do like to see them in the field, but I also don't want to see them too up close because they can be pretty threatening. So the one thing we do as well is we do carry things with us to protect us if we come across an upset bear or we upset a bear. But luckily, we've never had to deal with that. So yeah, polar bears definitely a highlight. Haven't seen them too often, but a few times.
Okay. I'm going to grab one from the YouTube chat here before we
Sure.
start. And this question has more to do with cold. What's it like to be spending so much time, so many days over and over in the Arctic?
Yeah, that's a great question. I think the coldest temperature I've been in was about it was in the minus 40s, like minus 45. And it was so cold that when you blinked, your eyes kind of felt like they wanted to freeze shut. Like the moisture in your eyes could hardly avoid freezing. And it is really cold. It can be very cold. But what I will say is the more time you spend in that environment, you do get used to it a little bit. And we have very good gear. So it all comes down to the clothes you wear, the little tricks we can use to stay warm. So we have lots of different layers that we wear. I spend a lot of time always trying to find the perfect glove setup because your fingers get cold, my toes get cold. It's always thinking about the best socks you can wear and the best gloves you can wear. If you keep your fingers and your fingers, hands, and feet warm, you're generally pretty happy. The other thing is keeping your face covered up. So the first thing to always freeze is the tip of your nose or the skin on your cheeks when it's really, really cold. So we have face masks we wear, things like that, ski goggles, things to help keep us warm. So definitely the more time you spend in the north and the more as you kind of perfect the clothes you wear and the gear you have, it definitely makes things easier. That's a great question.
All right. Well, I think we're ready to play a little Kahoot, and then we will finish off with some more questions. So I'm going to hit start on my end. There's some multiple choice. There's some true or false. The quicker you put in the right answer, the more points you get. If you're playing in the classroom and you're not connected, that's okay. Just shout out your answers and see how you do. First question to warm us up. Satellites can tell us a lot about our changing planet. Is that true or is that false? That satellites can tell us a lot about our changing planet. You've got a few more seconds to lock something in. All right. Good job, crew. That's absolutely true. We talk about space exploration and how we're exploring beyond the solar system. But we can also turn those cameras back on our planet and look at it in new, really exciting ways. Okay, let's go to our leaderboard and our next question. The Agent Ostrich is in first place. And we want to know, why is snow important? Does it provide fresh water? Does it reflect energy? Does it keep the ground warm? Or is it all of the above? So why is snow important? Providing fresh water, reflecting energy, keeping the ground warm, or all of the above? You've still got about 13 seconds to get something locked in. And then we will see how we do. All right, good job, crew. All of the above is the best answer there. Let's go to our leaderboard. The Daring Dingo slide into first place. True or false coming your way? Once snow lands on the ground, it stops moving. What do you think? When snow lands on the ground, that's it. It stops moving. That's where it stays. True or false? Once snow lands on the ground, it stops moving. Got a few more seconds to lock something in. All right. Let's see. There we go. False. Good job, crew. We know it blows around. It changes shape and compresses, and all kinds of stuff happens once the snow hits the ground. Daring Dingo is holding on. We've got one more question. What doesn't Chris do in the field? So you got to pick the one that doesn't belong here. Does he measure snow thickness? Does he take measurements from airplanes? Does he make new snow to replace what we're losing? Or does he examine the size and shape of snow? So 3 of those things belong there, are things Chris does in the field, and one is not. So measuring snow thickness, taking measurements from airplanes, making new snow to replace what we're losing, and examining the size and shape of snow. All right. Good job, crew. That one definitely doesn't belong. Making new snow to replace what we're losing. I think that would be a losing battle and much too small scale. So the Diplomat Leopard in third place. The Daring Dingo sliding back to second place, which means in first place we've got the Cute Macaw 75. All right, very cool. Well, thanks for playing along, crew. I'm going to stop that screen share, turn off that music, and then we're going to spend the rest of our time with some Q&A action. We've got some students hanging out backstage with us, some 5th graders in Ottawa. How are we doing today, 5th graders? There they are. All right, nice to see you happy and excited. I have a feeling you have some questions for us, so let's grab 1 or 2 of those. If you want to grab the mic for me as well. Looks like it's on mute.
Yeah, you're still on mute.
Yeah, I think they're just getting sorted.
All right.
We might see someone pop up at the camera in a second. We can also come back in a minute if you need a little bit of time to get sorted. I can grab a couple questions off YouTube. All right, let's give them a second to get sorted. With the mute, I'll keep an eye on if I see it unmute, then I know I can bring them back in here. Okay, let's start with a few here on YouTube. So we have Caesar joining us. Caesar joins us from home quite regularly. He's all the way in Nicaragua, which is pretty cool. And he wants to know what you like the most about your job.
That's a great question, Caesar. So, I mean, I think I think what I like the most is the variety that I get when I'm in the field. So every time we're out working in the Arctic, something happens that you can't predict. So the weather turns bad all of a sudden, or a snowmobile you're driving breaks, or a piece of equipment that you need to use to make your measurements fails, or something happens, somebody gets sick, or there's always a challenge that we don't anticipate. And so that keeps things very interesting and it keeps life challenging. And so having to be flexible, having to learn how to troubleshoot and solve lots of problems, I think that's the favorite part of my job. No 2 days, like when we're in the Arctic, no 2 days are the same. Something always happens that's interesting that you don't expect. You see something you don't expect. So lots of cool things like that are always happening. I think that's the favorite part, or maybe it's the main reason why I enjoy field work so much.
Yeah. Okay. Let's see. Joining us are some grade sixes, and they want to know. Um, you talked about having Indigenous people in the Arctic join you in the field, so they're wondering: is there anything you've learned from them that's really stuck with you?
Oh, absolutely. So, I mean, they, the community members, the elders who came and stayed with us, we actually had been in that community previously. And when we were meeting with them, they actually took us out on the land and they showed us, like, I've spent a lot of time poking around snow, studying snow, but I had no idea, how do you decide where the right snow is if you want to build an igloo? How do you decide where, when you're on a ice covered lake, where's the best place to go ice fishing? Where's the best way to travel? How do we travel through this really hilly area? How safe is the ice going to be beneath us? Things like that. They knew the landscape so well. They could tell us all about the snow properties that were in that area, and they taught us and showed us how to select the snow to build an igloo and then how to actually build the igloo itself. And let me tell you, my igloo was terrible. It did stand up, it didn't collapse on itself, but it was not great. But like just learning about the uses of the land, how to travel across the land from them, we've learned so much. And that's like that in every community we're in. We always um, benefit greatly from being able to work in partnership with the people in those communities. So that's a great question. Thanks,
Yeah,
Caesar.
great. So our fifth graders in Ottawa, I don't know if they were able to get the mic going, but they did put a few questions in the private chat for us. So let's tackle a few of those. So the first one's about air quality. When you go further into the north, what do you notice about the quality of the air?
Yeah, that's a great question. So as you move, into northern Canada, there's really no factories there. You get in the towns, there's some local air pollution because there's vehicles driving around. But in general, the the air quality is quite good. But what's interesting is, we often say, like from an environmental point of view, like what happens in the Arctic doesn't stay in the Arctic. So for instance, when ice caps, when the Greenland ice sheet is melting as it is now, losing mass, that raises sea level around the world. Whether you are in the Arctic or not, our sea level in coastal areas is affected by what happens in the Arctic. It's affected by what happens in the Antarctic. So changes to the environment that are happening in the Arctic don't just affect the Arctic. And by the same way, things that are happening outside of the Arctic move into and affect Arctic regions. So if we think about some of the big wildfires that we've had across Canada this past summer, that was really bad for air quality, not just where those fires are happening, but in places far away from that. So I live in Toronto. We had some really bad air quality this summer, even though there weren't any fires that close to Toronto. It's the same in the Arctic. They get affected by air pollution, by wildfire smoke, by other things in the atmosphere, because the atmosphere is really good at transporting things long distances. So pollutants, smoke, all these things, they can travel thousands of kilometers into the Arctic and affect the air quality there. So even though in general the local sources of pollution are fewer in the Arctic and the air quality is typically quite good, there can be periods of time, and they're certainly not immune to receiving pollution in various forms in the atmosphere because it can get transported a really long distance.
Okay. And they had one more question here in the chat about endangered species. So have you ever encountered any species that are endangered in the Arctic?
Yeah, well, that's a great question. So it depending on where you are in the Arctic, some species are sort of like the herds in that area can be more critically affected than others. So I showed you a photo of some caribou. There's some really massive caribou herds in Canada, but they kind of each one has their own territory in which they stay. So there's some caribou herds in the Western Canadian Arctic, in the Eastern Canadian Arctic, in the Central Arctic, And so some of those caribou herds are the numbers are healthier than others. So that's I think a cause for concern in some areas is the health of the caribou population. Kind of similarly in the past with polar bears, there's been some concern about polar bear population and the health of polar bears. Polar bears really need sea ice. That's their habitat that they thrive on, and it's the habitat in which everything that they eat or they want to eat lives on. So they hunt for seals typically who live on the sea ice. If there's no ice, they can't go hunting. They can't move about the environment the way they want to. So as our climate system is warming, we have ice forming later in the fall. It melts earlier in the spring. It's not as thick. So for all those reasons, the basic habitat of the polar bear is changing. So that's an example of how changes to our environment can have really important impacts on the animals that live in that environment as well. So that's something that we want to. I know I have colleagues at Environment Canada who do research on how polar bears are responding to climate change.
Yeah. Okay. Seventh graders would like to know, you're remote. So what do you do if something breaks or, even worse,
Uh-huh.
someone maybe gets hurt?
Yeah, that's a good question. So on the sort of the hurt side or the health side, we take wilderness first aid. So that means we're trained to do, some of the basic things. We can diagnose some injuries, a broken arm or things like that. We know how to set it, like little things like that. We're sort of trained to do. But you really just have to be extra careful. So even like little things, when you're lighting your camp stove, you don't want to burn yourself or burn anything. When you're preparing food, you don't want to cut yourself badly or anything. We just take extra precautions in how we deal with things. When things break, sometimes when things break, you look at it and you go, "That's broken. I can't fix it. I can't
Yeah.
use it anymore." So if it's a piece of scientific equipment, we put it away and we fix it when we get back to our lab here. If it's a bigger problem like a snowmobile, well then, we have to figure out how to deal with that. But you have to kind of diagnose what's wrong and think, can I fix this or can I not? And when we do fix it, oftentimes it's not pretty. Maybe it's some duct tape, maybe it's some quick glue job here or there. But you have to just sort of do what we can with the materials we have and then solve the bigger problems later.
Okay. All right. Well, Chris, I want to start off with a big shout out to our classrooms. We had a great group with us today, sent in some great questions via YouTube. A shout out to our fifth graders in Ottawa who sent us in some great questions via the, excuse me, via the private chat. And Chris, most importantly, thank you so much for letting us steal a little bit of your time. In fact, maybe I'll squeeze in one more question, Chris. It just came
Sure.
in via the chat. What about myths or stories you've heard from the communities in the Arctic? Is there a story that you heard that you really liked that really kind of stuck with you?
Oh, that's a great question. So, I mean, I think there's a diversity of different stories and things we hear depending on which community we're in across the Arctic. I worked with some colleagues a couple of years ago on a report where we were kind of thinking about what the future of Arctic research could look like in Canada, and the one of the animals that came up in the mythology that we tried to use to help frame that report was the raven and the wolf. These are sort of keystone species that many of the communities, our Indigenous friends, plays a really important role in the mythology for them. And so the raven as kind of a strong creature, a wise creature, but also not afraid to cause some trouble. I mean, that's the mythology around the raven that I find fascinating. So I'm the wrong person to go into too much detail on that, but I do encourage you to do some reading on this because the systems of mythology that you can read about are deep and rich, and so I would encourage you to do that.
Excellent. All right. Well, once again, a shout out to our classrooms. Thanks so much for hanging out. We hope to see you in some more live events as October continues on, especially with our space exploration stuff coming on over the next few weeks. And Chris, again, great to steal some of your time. Thanks for the work that you do and bringing back that data for us about how our Arctic is changing. And we know it's changing faster than other ecosystems on the planet. So it is really important that we're getting that data.
Absolutely. Thanks, Joe. Great to be here. And thanks, everybody, for listening and for your great questions. I really appreciate it. See you all
All
again.
right. Thanks, everyone.
All right.
Signing off for
Thanks.
now.